In the second part of this video, we're going to talk about how the control unit manages executing the instructions. In the first part, we talked about how the control unit manages fetching instructions and decoding instructions. Now we will turn our attention to executing. Uh, the way that instructions are fetched and decoded is identical. The way that they are executed depends upon the instruction. Also, it depends upon the category of instructions. So we will sample a couple of instructions. We will start with load and store. So what happens with load? Well, if you want to load, the op code would be 3, and the operand will be an address, and it's a data memory address. So the address in the operand field must be sent to the data memory unit. Also, a signal must be sent by the control unit to the data memory to do a read. The read results in data coming out of the output port. And this data that comes out needs to be placed into the accumulator. So let's look at the steps over here. What's in the instruction register is placed, the operand field of the instruction register is placed in the data memory address port. A read signal is given, and the result that comes out, the data that comes out, is placed into the accumulator. What about a store? Let's think about that for a moment. To store, you need an address. So the step of putting the instruction address, the, the operand field of the instruction into the data memory address port is still required, followed by the movement of what's in the accumulator into the data slot, followed by a signal to write. So this is shown here. Yipes. Down here. So this is what a store looks like. Now, what about arithmetic? The computer contains a unit. The control unit also controls a unit called an arithmetic logic unit that basically does all the calculations or data transformations. So when I want to do an addition, I need a left operand and a right operand. The left operand comes from the accumulator. The right operand comes from data memory. So in order to get the operand, we must first read from the data memory. But the read has to be preceded by putting an address so that when the read instruction is issued, that when the read signal is given, an address is present. The data that is at that address is read and is placed in the output um, port, output region, and that data is what needs to be sent to the ALU as the right operand. Then the ALU does its operation and it produces a result. Again, the ALU has two inputs, left and right, and it has one output called out. So that describes add. Notice that most of the multiplication, most of the um, arithmetic operations that involve data memory work exactly like this. The thing that will be different is the signal that you send, the operation that's being performed. Now let's see what we have next. If we have the immediate instructions, remember we have immediate instructions, and the instructions do not contain a data address, they actually contain a data value. When that is the case, the movement of data to the ALU is much more simplified because basically the accumulator goes in as the left operand, and the right operand is just the address or the operand field of the instruction register. The signal to add, followed by placing the result in the accumulator. So the immediate instructions do not need to access the data memory. Now let's see what's next, see what comes next. Now, the arithmetic logic unit also performs compares. If you look at this microcode, you may be surprised about how compares are done. Compares are really just subtractions. If two numbers are the same, when I subtract them, I get a 0. If the left number is less than the small one I subtract, I get a negative, and so forth. So basically, the compares use add and subtract. The method of preparing the operands and sending them to the ALU are the same as if you were doing add or subtract. But once the ALU operation is completed, the subtract is completed, an additional step is done where the accumulator is set to true or false. Finally, let's look at branch instructions. Unconditional branch simply says take the address in the instruction and place it in the IP. That's all. A branch on true simply says check the accumulator. If it's 0, if it's 1, then place the instruction, the address from the instruction into the IP. Now the subroutine calls are forms of branches, but remember that a subroutine call says that I've got to save the IP. I got to save the address of the next instruction into RR, and then I will put the address of the subroutine, which is the operand, into the IP, which basically says the next time an instruction is executed, we go to the subroutine. A return is simply placing the return register, the content of the return register, into IP. So that's what a return is. That's all that is, right? All right. With that, we're going to quit. I hope you get a feel for this. And